All right, welcome to our end-of-line palletizing and packaging webcast. So it's really important today that if you guys have questions during this webcast that you add them to the chat area. Jim will be watching that chat area and he will get to those questions when the speaker is in the middle of that topic. That way we can be right on topic. So I'm going to go ahead and introduce our host today. Our first host is Earl Raynal, and he is our sales development manager. He has been in this business with 30 years of experience in robot and automatic guided vehicle automation. Earl has creatively applied end-of-line solutions to manufacturing and warehouse distribution facilities. Earl works to effectively collaborate with each end user to safely reduce costs, meet goals, and improve productivity. And our co-host, Director of Sales and Marketing, Jim has over 25 years of experience developing innovative solutions to overcome challenges and ensuring that ownership goals are met or exceeded. Across multiple industries, Jim has successfully integrated end-of-line systems for large companies with diverse products in a global market. And then finally, our guest host from Fanuc is Josh Holtzberg. And Josh is an experienced engineer with a 20-year history of working with industrial automation. He is experienced with machine vision, high-speed picking, palletizing, warehousing, and process control.
Yes, thanks, Nicole. Looking forward to our discussions today and getting this thing underway. Thanks again for having me.
All right, thanks for joining us, Josh. I'm going to turn it over now to Jim Skelding, and he is going to explain exactly what end-of-line solutions are.
Thanks, Nicole. Just want to start out with the definition. What exactly is end-of-line automation? End-of-line automation is the assortment of machinery, equipment, and software that are integrated into the complete the shipping package before the final transportation of the goods. Typically, the process begins immediately after the individual product is made, filled, or converted. Available on our website at Motion Controls is this interactive web page that you're seeing on the screen. And we're going to start up in the left upper corner. We start out with robotic or traditional case or carton erecting, then go to each picking or case packing, then do case sealing. From there, you'll see our patent pending robotic tape inspection, inline case labeling or check weighing. And here is where any other quality control or customer specific processes could be implemented. From there, we show a single line palletizer cell for one product, one pallet, robotic case sorting, single row palletizing with pallet dispensing. Following through to the center of the screen, you see another complete system where we have full layer building and palletizing with a palletizing robot on a rail that allows us for multiple palletizing position and sorted by SKU or order. Finally, the pallet loads you'll see are shown being transported by several different vehicles, AGVs, automatic guided vehicles, AGCs, automatic guided carts, and AMRs, autonomous mobile robots, allow you to transport the pallets or the unit loads from the pallet wrapping system then out to the shipping docks or into the warehouse. Any or all of these solutions can be integrated into your process to increase throughput, eliminate labor issues, and reduce costs. So now I'm going to turn it over to Earl for our first topic. So go ahead and take it away, Earl.
Thanks, Jim, and thanks everybody for joining us. Just looking at the list of attendees, I see Riz is out there. You better be nice to me. This is my first webinar. So yeah, let's get on with it. First thing we're going to look at is a trend that we're seeing more and more of, and it's basically a way to increase the utilization of robots. specifically palletizing robots. So we've got these multi-use robots that are not only palletizing finished cases or bags or product, but also doing some little bit of upstream work. In this case, we're handling rolls off of a winder. We're moving blanks into a box folding station, some automation that we've designed and built, and then placing the roll into the box. A tape roll, an optional tape roll can be added to the package. And I don't know if you can restart that, Nicole, but you've got a multi-purpose end of arm tool that can handle blanks, handle rolls, and handle the finished carton. So we've got, when cycle time allows for it, we've got the ability to use that robot for multiple purposes. And again, I think that this it takes some design and some thought, but we're going to be seeing more of this type of thing in the future. Tray erecting, as the big box stores are demanding point of use or point of sale packaging right off of pallets. We're seeing more and more where our customers want to have trays built or pallets built with trays and tier sheets. So here we've got a robot that can build the tray and then go ahead and stack product into the tray. Along those lines, for flexible tray packing, we've got we've been designing end of arm tools with zones on them. The zones allow different configurations of product, pre-wrapped product, to be packed either directly onto tier sheets or onto larger trays. In this case, in this instance, this robot has the ability to handle 2x4 product arrays that are shown here, 2x6, 3x4, 3x6. So depending on what the product is, the robot can be easily switched over from one configuration to the other. Modular palletizers, we're seeing more and more of these. You might be seeing some advertising coming out recently with collaborative robots in very small, tight palletizing cells that can be moved around from station to station. Very nice little niche solution. These smaller, simpler cells tend to be limited in their, or they are limited in their capabilities. So you have, you typically lighter case loads, less variation from product to product. But in a really simple, elegant solution, these could be built onto an 8x10 or a 10x10 platform and then moved from line to line as your production needs require. Resealable pouches are, they've been around for a while now, but they seem to really be taking off recently. And robots are stepping up for case packing very nicely. In this case, in this instance on the left, we have a robot that can stack pouches vertically and horizontally into cases. The soft robotics gripper is shown in the middle here, is a really nice plug-in unit that can handle a wide variety of product. It's a scalable design, so you can have more than one pair of fingers for heavier product and so forth. But again, all geared towards unusual or product with variation in it, like pouches, food pouches. And then on the right, when needed, we can do some for higher speed applications, because these food pouches tend to come in at very high rates. We can pre-order the pouches upstream and then put gangs of grippers onto the robot and pack one or more cases at a time to increase throughput. Robotic tape inspection. We're going to be talking about central case packing here in a moment. And one of the issues that has been a challenge over time have been cases that get to a central palletizing area from the production area with bad tape. And tapers are reliable, but they tend to have issues. They run out of tape. Occasionally they get gummed up, that sort of thing. So the worst thing that can happen with a central palletizer is to have one of these boxes come open, and then you got a mess that in your stopping your palletizing operation. So here we have a inline robotic tape inspection process, very high speed, watches for case orientation, and can check for presence of tape on both the bottom and top of every case that comes through the system. Automated labeling, tremendous amount of activity happening in this area. And I'll just say that incorporating automatic labeling into a robotic palletizing cell or any type of robotic automation is pretty straightforward, and has helped our customers with 100% traceability and accountability for products being made. In this case, in this instance, we're palletizing both boxes shown there, and then these rolls that were shown in the lower right. The robot has the ability to go to the same robot goes to the inside of the roll and places a label inside there. And then if you could hold that just for a moment, Nicole, I don't know if you can go back or not, but the previous slide had an application for the previous video, high speed print and apply, and we're hitting upwards of 80 labels a minute on product going by that we're tracking visually. Additional finished pallet labeling, again, all geared towards 100% labeling a product, eliminates operators, eliminates tedious work, errors, and so forth. Very high reliability operation with the automated labeling. This is back to that high-speed labeling application. Here we had a customer with a very specific requirements for label orientation and location on a product. So upstream of this, we locate the product, then we print the specific label for that product and place it in the right place and to very tight tolerances. So this was a consumer goods manufacturer, electronics, you might take a guess at, and they were thrilled with how accurately and how quickly we could get the labels on, and then verify that the label was there and that the label had the right content in a downstream vision operation. Depalletizing and re-palletizing, again, getting more use is a trend we're seeing more and more, getting more use and utilization out of a robot. We're taking, we have the ability to depalletize and re-palletize for specific orders and customers. And then in a number of cases where we have customers asked us to break down a pallet, apply labels to individual cartons, and then re-palletize for end customers. And this is related to the online business, that's online sales business that's been happening. So next. Case tracking and traceability, mentioned this a little bit already, but again, something that's very just a natural fit for robotic palletizing applications. In this instance, we're using both Cognex and IR Vision to track individual cases and locate them on the conveyor and feed information to these robots so that they know, the correct robot knows which product to bring into a palletizing station. Small footprint vertical lifts specifically for central palletizing solutions. I really like this new product. It's been around for a few years, but I think it's getting some traction now. Starting in the upper right of the right-hand photo, the traditional way to get cartons and cases up in the air for horizontal, long-distance horizontal transportation is an incline conveyor. Those take space. The spiral lifts are expensive. The Z loaders are slow. These new vertical lifts are integrated vertical lifts are they just have a nice tight footprint, fairly high rate capacity, and can be configured in a number of configurations. So the cartons and cases can come in from the side, from the front, can exit from the side and front as well. Automatic guided vehicles. I want to talk about this a little bit. There's the new buzzword is AMRs, or automated mobile robots. And as far as I'm concerned, these are all automatic guided vehicles. Back when laser guidance first got traction in the, I'll say, late 80s, early 90s, you know, that group of suppliers wanted to call them LGVs instead of AGVs because they were laser guided. These new AMRs are vision-based and more slanted towards software layout rather than physical layout. But at the end of the day, they're automatic guided vehicles. So I just want to step through these real quickly. The base T car, transfer car, has been around for ages. It runs on a rail, connects conveyor. The M car is a variation of that we've come up with, and it's a derivative of a smart cart, a Jervis B. Webb automatic guided cart, branded as a smart cart. We have taken that and replaced the T car in many instances with a vehicle that has simple controls but can go around corners and turns rather than being tied to a rail. The smart cart would be, or other automatic guided carts that are out there, are typically tape guided, sometimes inertial, sometimes laser guided, but less expensive flavor of automatic guided vehicle. And we're getting a lot of use in those for pallet handling and pallet transport of finished product from central palletizers to wrappers, or from wrappers to warehouse applications or warehouse areas. Automatic guided vehicles, you can see in the background of this slide, there's an AGV, traditional AGV in this case, with 2 conveyor beds for added throughput. And again, those are typically laser or inertial guided. I wanted to point out this kind of a special class of AGV that's got has had some unique installations with us for unitized loads. So we come in with a clamp rather than forks. And that clamp has the ability to handle a unitized load, no pallet, and put, in an extended case, put a full unitized load onto an over-the-road trailer from the wrapping stations. And then finally, the AMRs. And again, it's a little different. It's a variation, but it's still a guided vehicle. And we're starting to see these. They're typically lower capacity units at this point. I expect them to grow and evolve into more full pallet handling type platforms. There's a lot of suppliers cropping up out of the woodwork, but I believe they will sort themselves out, and we'll probably see the traditional AGV suppliers that are out there today absorb this type of technology. Next. Sorting and layer building. I'm gonna hand this off to Jim. He's got some words to cover on that.
All right, thanks, Earl. What I'd like to start out with is an MCRI case study we did recently for a food and beverage customer. The challenge was we had a sort at a high speed wrap products coming out of a flash freezer in a cold room environment in excess of 75 parts per minute. Here you can see a pair of Scaras robots from Fanuc that sort the product from a single mixed in-feed lane to 3 different robotic case packing lanes, each one of those outfitted with a Fanuc LR-Mate robot. You know, as the products approach the Scaras robots, we used Fanuc line tracking software, and which we use to assign its destination and track the product travel as it approaches the Scaras. The Scaras catches the product with a custom end of arm tool and slides it to the appropriate product lane. The quill or the vertical portion of the robot, where the end of arm tool connects, moves up and down very quickly, and allows us to not block the upstream product headed into the robot. At the end of the sorting lane, the product is picked by the LR mate, and then we're shingle packed in a 6x2 pattern inside the case. Now, the lessons we learned on this was that the Scare robots are extremely flexible, reliable, and can be used at low and high speeds that require little space or little space. Excuse me. The thing to note is here is the Scaras are also the lowest cost robot in the Fanuc product range, and also incidentally, this product is in process here at Motion. So stay tuned to our social media for videos later this summer. Moving on to case sorting, divided into a couple of categories, large and small of case sizes and weights. Typically, for the small, we'll use the Scara and the LR mate family of robots that can be used to achieve rates of in excess of 75 cases per minute. The larger cases size, as you see popping up on the video now, we use the M10, M20 family, and occasionally we'll use the Fanuc M410 110, which is labeled by Fanuc as the fastest palletizing robot in the world. And those range, from 10 to an excess of 20 cases per minute. In the video you see here, what's happening is this Scare robot is sorting and diverting these cases from the main conveyor line into the appropriate sorting lane. The Scare can either maintain the narrow edge leading after it is sorted in the video that we show, or we can actually change it to wide edge leading if the project requires, and can go back and forth to do that if the pallet pattern requires. So moving on to the layer forming video, next one, here you go. So what we're doing here is we're using a vision-based label scanning system upstream of the palletizer that scans each case, which tells us two things. It first tells us which lane it's going down, so the correct sorting robot can pick it off of the main feed line. And the second thing it tells us is that what layer pattern it is, so that when that robot releases that case, as you saw there, was different from the first, it makes sure that that layer is built in the proper orientation. There you saw the layer then get released and then goes into the palletizing robot, and it's picked and palletized in the appropriate station. Okay, in our traditional layer building, in the picture, we'll let this loop through a couple of times, but in the picture in the lower section, you'll see the front half of this. But traditionally, layer building devices that are non-robotic require bump turns, interlocks type conveyors, and other mechanical devices. More times than not, these require additional floor space, and with a wide range of case weights and sizes, can sometimes cause problems when there is a need to reorient or transfer the cartons prior to the palletizing. So in the video, you see the operator uses the HMI to designate the layer pattern to be run on the system. This system, which we'll get to a little bit later with some more videos, is a 4-in, 4-line out palletizing. So it can do 4 individual SKUs at one time and palletize 4 pallets at one time. So as you see, we utilize the M410 palletizing robot and a unigripper full layer vacuum gripper end of arm tool. Cases are manipulated with the bump turn upstream, the retractable stop, and the interlocks conveyor system builds and orients the layer in the proper position. Then once that layer is complete, the retractable stop releases the layer, and then the robot picks. So as you can see them there, each individual lane is identical, and we're building a multitude of sizes and shapes of cases So now I'm going to turn it back or turn it over to our guest host, Josh Holtzberry, and he'll present, Fanuc America's range of palletizing robots and software. So Josh?
Excellent. Thank you, Jim. I appreciate it. And thanks again to all the team at Motion Controls for having me on today. So we look at everything that kind of Jim and Earl have talked about, and a lot of at the core of what that is our Fanuc palletizing lineup of robots. Within that palletizing lineup of robots, you've got the screen that we'll go through right here that's going through basically all the different manipulators that are somewhat specified or specifically built, not only just for general purpose, but some of the larger ones for palletizing only. And then on the flip side of that, you've got the software that we'll kind of run through as well, that runs on the not only the robot, but also your PC. When we look at this chart here, it's just kind of a nice graphic that gives you a feel for just the wide range of product that we do have within the palletizing lineup. All the way from the lower left-hand corner, where you'll see some of the collaborative robots, the smaller units, where you'll see more and more folks trying to use those on single end-of-line palletizing systems, where they're dropping right in off the end of a current setup that currently has an operator or two there. And as we move to the upper right, we go through some of the higher speed, higher duty, but smaller palletizers like the 710s and the R1000, the 410 IC 110, which is the fastest in its class, but again, a nice compact design that allows you to kind of try and get it in a lot of those cases where you just don't have a lot of room, but you need the throughput. And then that chart goes on through the 410 185, which is kind of our bread and butter, our starting point for any of the standard palletizers, up through the 315, 500, and 700. That slash and then the number behind there designates what the payload is for those particular arms themselves. You'll see on all of the larger units, all the 410 IC 185 and up sizes, they're generally around that 3,000 millimeters of horizontal reach. Now their vertical reach runs in tune, and that's why the design of the arm looks like this, is more of a rectangular shape to get that full 40 by 48 inch pallet at that 110 inch height that you would see for a full pallet load going onto a box truck. Before we move on to the software and a couple of the other unit load pictures that we'll see here, I want to point out, the key piece of this puzzle too is just the efficiency, reliability, the off-the-shelf portion of this that comes in play with a robotic palletizer versus your old traditional drop palletizers or the mechanical devices that you may come across out in the field that generally have a tremendous amount of maintenance required, a lot of custom moving parts, just a lot of moving parts in general, which makes for a kind of maintenance nightmare down the road. So a lot of these arms, right off the shelf, standard products that we've been making for a very long time, and quite frankly, standard products that Motion Controls has been using for a very long time as well. So as we move forward, you'll start to see some of these different, I just wanted to kind of give you a brief overview of what that standard stack height looks like with regards to some of the different size arms. As we mentioned, the 185s, 315, 500s, those all have your standard 110 height. Smaller units, not quite as high. You can offset some of that maybe with putting the robot just on a stationary riser. Sometimes they need to go on a riser anyway to get over conveyance and things like that. But this gives you kind of a feel for all the wide variety of the products that we have out there. These are the larger ones. The next slide will show you. We'll kind of give you a quick rundown of the collaborative side of it. Again, everybody hears that buzzword of collaborative these days, and not everyone's really sure where to use them. A lot of end users get the edicts coming down from top down saying, hey, we got to have these collaboratives. It's all the rage, and what drop the thing in and off you go. Sometimes that's not always the case, but the point with all of these different palletizing arms is we do have a solution if indeed it is a good collaborative operation, or if not, we've got many other solutions in what we always consider our standard yellow arms that we can utilize as well. Just a quick rundown on this. Obviously, the heights for these guys a little bit smaller than what your standard palletizing arm generally is designed to handle. The collaboratives, there are some different devices out there like Z-height kind of elevators that will bring the robot up and down as an aux axis to then get to that 110-inch height that you might need. But again, those are kind of some ancillary items that you may or may not need. You know, that's really where your authorized systems integrator comes into play, to be able to take a look at that application and not just kind of jam a round peg into a square hole, but take a look at what you're trying to come up against, what it is that your constraints are, and then choose one of those, 20 different arms that are going to meet the requirements of what your production looks like. Part of that is when we look at some of these software tools and what we can utilize to make sure that you get to that point before the thing hits your floor is our pallet tool. Pallet tool turbo is what runs on the robot itself. This picture that you see here is a screenshot of Pallet Pro. So Pallet Pro meaning the software that runs on your PC. Pallet tool is the software that runs on your robot controller. Pallet tool is the core software that you would be running in production. A quick kind of one-hitters here, up to 100 units per layer, 40 layers high. The ability to palletize from up to 16 in feeds, 16 outs. But that being said, there are going to be cases where you have an end user that has a requirement outside of those constraints. And when that happens, then folks like Motion Controls, who have been doing this for many, many years, like I said, have the capability to devise and develop their own software to make sure that it meets all of the requirements for what you're looking for. It is very, very user-friendly, and there are many, many tools to help you along the way, but our software always is going to give you the ability to customize, because we know not everybody has the same situation. So, like I said, Motion Controls, who has been doing palletizing for many, many years, has those come up against those scenarios quite often where they need to utilize, yes, our software, but kind of tweak it to meet their needs, and we're fully capable of working together to do that. Here's just a few features that the Pallet Tool comes into play with, Pallet Tool and Pallet Tool Turbo. Again, standard palletizing teach pennant programs to really get you going quickly. It supports both case and bag palletizing. It can create your unit loads for you. If you are in a situation where you've got the set size of case, but you do not already have a pattern developed for it, the Pallet Tool or the Pallet Pro software will develop that and optimize the placement on the skid based on what your sizes are. Supports mixed layer or homogeneous unit loads, easy changeover. That's the whole point, is to be able to program and take a look at what these rates are going to do and what these unit loads do. Live 4D graphics display on the teach pennant to give you a better feel for what that looks like without actually running through it. Built-in support for servo grippers, PLC interface ready, the ability to palletize again from 16 ins and then 16 outs, and so on and so forth. So that's kind of just a quick hitter on the Pallet Tool side of it. So this is what, again, would be running on your robot. Now, the precursor to that, and really what makes for a good palletizing system, is doing your homework. Just like any other project that you're going to get into, whether that's a home project, something at school, or a robotic project, you really need to do your homework up front to make sure that you don't get yourself into a jam, down the way. You certainly do not want to be in a situation where you take all this time and money and effort, install a system, and it gets there and you're like, oh crap, this isn't going to reach, or it's not going to make rate, or the payload is far exceeding what we anticipated. What you can do is utilize our simulation software. We live and die by it at Fanuc. I know Motion Controls does a tremendous amount of work with it, but it gives you the ability, before you spend a dime on anything, it gives you the ability to validate throughput. Take a look at your duty. Not everybody takes the time to understand the duty cycle of what the arm can handle. It might be able to handle the payload, the reach, the throughput, but depending upon what those positions and what that movement looks like, you may be far exceeding the duty of the arm, which can quickly degrade the actual life cycle or longevity of the arm between preventative maintenance schedules. So if you don't look at that duty cycle and understand what it's doing to those motors, you might get down the path and understand that, oh, this thing is not going to last the 20, 30 years that it should. So we can take a look at all of that. We can take a look at the duty. We can take a look at the payload. We can take a look at what the rates are going to do. You can optimize your positions, because that will have a lot to do with what your overall throughput is, with what your positions are of the robot, with respect to the pallet, with respect to the infeed. All of those things come into play and can affect your throughput quite drastically. But we can take a look at all of that beforehand, and motion controls does a tremendous amount of that to make sure that they don't get into those positions. A lot of those different simulation videos that you saw earlier, those were all done with the RoboGuide software. This picture here shows that green outline. That's part of our DCS, our safety package. It allows you to set that up. And then once you get everything done and ready to rock and roll, now you can take it, dump it into your controller, your actual robot controller that's sitting out there on your floor, tweak things in, teach the in-feed and the out-feed positions, and off you go. So I know that's a quick rundown of a lot of information, but the main thinking points or talking points being, there's a tremendous amount of options and support available to you, through motion controls with Fanuc on just straight palletizing operations and applications. So we're always happy to help out. And again, thanks again, guys, for giving me a couple of minutes here to talk about our products. And I know we'll be on the line here afterwards if anybody has any specific questions after you go through all the rest of the presentation. I think with that, then we're going to hand it back over to Earl, who's going to take us through a couple of other applications and scenarios.
Thanks very much, Josh. And a thought occurred to me as Josh was talking. So far we've been referring to cases and case palletizing and to a smaller extent bag palletizing, but really anything that needs to be placed in an array that looks like a pallet. It could be very small components, could be large items. It can be handled with this this pallet probe and pallet tool set from Fanuc. So I would say, we're talking about cases, but we've got a tool set here that can be used on very small robots, very large robots, small product, large product, everything in between. We're going to look at, excuse me, some different palletizing configurations, and try to get a better handle on what thought process we go through at Motion, and what thought process an integrator will go through when we assess these projects. Here's a slide that shows two different palletizing concepts. One is a single line palletizer, where we'd have 4 of those adjacent to each other with 4 separate lines feeding in. And then over on the right is a single robot with 4 infeed lines, and the robot handling all the throughput from those 4, a single robot handling throughput from all 4 lines. So let's talk about a little bit more in depth on what, why you do one versus the other. The pros, if you will, on the single line palletizer are that you've got a very scalable modular system, can be easily scaled. You can start out with a single palletizer and grow as your throughput grows, and at a relatively low incremental cost. You don't have, if you don't have the production needs for a 4-line palletizer, obviously you don't want to buy a 4-line palletizer. Also, smaller products, you can use smaller robots. Smaller robots typically are going to be less expensive. If you have a need for all 4 lines up front, excuse me, and you're comparing 4 single line palletizers to a single 4-line palletizer, your 4 single line palletizers are generally going to take up more floor space, and the cost for the 4 palletizers together are going to be higher than the single 4-line palletizer. And then in terms of scalability, again, if the product already exists, the scalability is less of an issue with with the compared to the overall cost of a 4-line palletizer. Can we go to the next slide? So on the single 4-line palletizer, again, the advantages here, typically you're going to be looking at less floor space to accommodate the 4 lines. You're going to have higher case rates. With what's going on in this particular palletizer is that the palletizing the layer forming is happening upstream, which takes the load off of the robot. So now I can handle full layers at a time and get more production out of a single robot. The robot itself is going to be more expensive. The vacuum system is definitely a power drain on something like this. Arguably, there's more complexity to this sort of a palletizer than the individual four lines of single line palletizers. So again, pluses and minuses. We're going to look at any integrator is going to look at the mix of your SKUs and the throughput. And when I say SKU, I'm talking about stock keeping unit or a particular product that's being palletized. The integrator is going to look at a balance between, or what the balance is between the number of SKUs and the throughput for those different SKUs. Yeah, there you go. So another element of this consideration that we do, this measurement, if you will, to select the right solution for you is, it really gets back to the SKUs. On the left, we're showing a robot on a rail. When you have a very low throughput rate per SKU, but many SKUs, and I'm talking about generally more than 4 or 5 SKUs, then perhaps the best solution is going to be to put a robot on a rail and allow the robot to extend its utilization or extend its use across more SKUs. So that's what's shown on the left. And on the right is back to the idea of a single robot being able to handle 2, 3, up to 4 different SKUs. There are actually configurations where pallets can be arranged in a radial pattern around the robot. So instead of just being linearly oriented to run straight away from the robot and being limited to about generally 4 SKUs, I have seen radial patterns up to 7 SKUs per single robot. So it gets that gets a little trickier in terms of infeeds and some of the other maintenance issues and access issues, but it is an option. So we've got these tools, and we can employ them based on what the specific requirements are. We're going to look here at central palletizing, and the basic idea here is bringing cases or cartons in from around the plant into a central palletizing area. Go ahead to the next slide. In this configuration, this is set up as a scalable system. So SKUs can be added. Basically, if you carve out the floor space and you don't need all of these palletizers right up front, you can add them incrementally. And in this instance, we've got 2 lines coming into each palletizer. Yeah, so that's the basic configuration. And if we go to the next slide, rather than those 12 individual robots handling 2 SKUs each, this is actually an exercise we did for the same customer where we're still handling 24 SKUs at a time, but we have a combination of 4-line row palletizers where the robot's handling a row of product at a time. And those are the 4 palletizers up towards the top of the screen. And then 2 high-speed layer forming palletizers down at the bottom of the screen. You say, well, why would you do this? In this instance, the customer wanted to run up to 24 SKUs at a time, but there was a real wide variation in SKU throughput. So rather than building a whole bunch of expensive layer building palletizers, and having more throughput capacity than we really needed, or rather than having the 12 individual robots with excess SKUs, but maybe not enough capacity, we came up with this hybrid system. So the hybrid gives us the benefits of high speed for specific SKUs and a little bit lower throughput for some of the other SKUs. And then upstream, there is this switch system that allows us to route cases from any line out on the floor to any of the SKUs, depending on the production rate for the particular SKU. And yeah, this is, so just to reiterate, if you could, Nicole, maybe jump back to that just for a moment. That previous slide. Again, just to reiterate, here's the 12 robot solution with the 24 SKUs. And actually, this is going to take more floor space, and it's going to be more expensive than that hybrid solution that I showed you in between. Now go ahead. I just wanted to show you what the robot on a rail looks like. I'm going to say generally, if you can get away with 2 or 3 palletizers, palletizing robots, you're going to be less expensive than the robot on a rail. You need to have 7, 8 or more SKUs with relatively low throughput each to have it make sense to add the cost of a rail. The rails are somewhat expensive, but as soon as you get past that point, then the robot on a rail can become more cost effective for you. And we'll take a quick look at different palletizing tools. Just to give you an idea, robot palletizer doesn't have to palletize just one product. Here we're handling cartons and drums in the same system. Next. Here, end of arm tool can handle pallets as well as tier sheets and these rolls that you see on the infeed conveyor. And towards the end of the video here, you'll see the roll get picked up by the robot with another appendage on the end of arm tool, flipped down and stacked onto a pallet. So pretty nifty end of arm tool there. Bulk palletizing, here's a magnetic gripper. We've done a number of magnet grippers for metal, obviously ferrous metal products. And that's a nice option to have in our toolbox. And here's a very sophisticated end of arm tool. It's actually built by Schmalz. We work with them on this, a number of these projects where we can pick a full layer of virtually any product. So as long as the SKU is the same per layer, we can handle pallets that have mixed layers on them. And the use here is to take bulk pallets coming into a distribution center, breaking them down into individual layers, labeling the product, and then getting ready to send out and re-palletize downstream for either for individual stores or for other distribution centers. And here you see that same tool setting the product down on a stripper table. If there's a tier sheet, we'll push the product off the tier sheet and then go get that tier sheet and put it in a dunnage stack. Go ahead. And then I think this is the last slide that we have on grippers. I just wanted to mention PIAB has a new very high efficiency vacuum generator and cup combination that we were able to use in a cold room environment, which is a notoriously difficult environment for vacuum. And we're just thrilled with it. Customers were handling 140, 150 pounds per pick, per robot pick, and not having any issues with drop cases, which was a problem with the customer's previous palletizer. Oh, I don't want to forget about 3D printed grippers. In this particular application, the customer came to us with a very weak jug. They're just like aluminum cans. The jug people are driving weight out of the product, making it, I'll say, more flimsy, difficult to handle reliably. And we came up with a 3D printed gripper that very cost effectively secured the handle of these jugs so we could move them at a very rapid speed. And I'm going to turn it over. We're going to run out of time here, but I'm going to turn it back over to Jim, and he's going to remind everybody what we need for a good palletizing system.
Okay, Earl, thanks. That's good stuff. So I just want to wrap this up with a couple of key points to, that are very important to the customer integrator relationship. Just an FYI, we have an RFQ, a request for quote template, that will go into detail of all the different components we need here. Task us either with an email or put us on a chat, and we can send that to you. You're welcome to use it for your next project or just to get a sense of what you may need. So going through these, next one to project information, these are your basics. Rate in this business drives everything. Rate will determine size of equipment and the amount of equipment. So those are number one. Product dimensions, certainly min-max sizes and weights and descriptions of the products. The packaging, the unit load requirements. So these are your pallet patterns, your pallets, if there's multiples, layers, etc. Unit load requirements, which are part of that as well. Your packaging specifications. So if we're putting tier sheets in between layers, we're corner boards, let's say we're top sheet plastic, or we're shrink wrapping it or stretch wrapping it. The equipment interface. So if we're interfacing with a converting machine or a automatic case packer or filler, all the way to maybe an existing wrapper or stretch wrapper or bander, etc. And then of course documentation. We're going to need a layout drawing. It's always best to have part drawings and actual images of the pallet patterns, so that we're can accurately quote how we're going to create the unit load. Next. I'm sorry, there you go. Cost justification, and Earl and I were talking about this when we were reviewing this morning, and it's like customers don't want to tell you how much money they have to spend, but I'm going to jump to number two, because the reason we need to know a range there is it allows us to make sure that we're providing the system and it fits into a number or a range. We don't want to sell you more bells and whistles or include options that we're certainly going to blow it out of the water. You're going to get sticker shock and move on. So that's kind of the reason that we need that. But just keep that in mind, and I've got something else on this here in the next slide. But basically, how you're paying for the project, headcount, labor savings, safety, or increase in production, and then of course, the shutdown and the installation phase. Are we doing it all at once? Are we going to have to do it while you're running? Those are all super important when it comes to figuring out what the proposal will be. And then finally, moving on to this, obviously, what things that you, as the customer or the guy writing the check, should ask from their integrator. Definitely ask for a layout and a budget price. If you're not going to tell them a range, if you ask for a budget price up front, you're certainly going to know if the system is going to fit in. So you don't have to go further down a road that may not work for you. Rate confirmation. Make your integrator do a simulation or at least a detailed time study to say, prove to me you can do 50 cases a minute, like you're saying. Installation, commissioning, training schedule, and the warranty. What's included in the warranty, but how many days are going to take you to install? How many days are you going to commission? And then how many training days are you going to give me? Those are all key. The last two are certainly important, and there's some mix here. So videos and pics of their solution. If they're saying they can put a widget into a box standing on their head. If they don't have videos or pictures, probably they've never done it before, and maybe it's time to move on. And then integrator background check. This is really important as robotics in the world today become more in your face and prevalent in the market face. There's a lot of new integrators out there that are just buying robots and trying to integrate them. So first of all, ask for recommendations from guys like Josh Holtzberry at Fanuc America, the OEM of the robot, and give their recommendation. Look at your industry specific member organizations, the RIA, et cetera. And a couple other gotchas that I'd throw out to you is, websites like Glassdoor, where it's a verified site that allows employees to rate their employers. So, find a little bit about them there. And then lastly, I'd ask you to go to Google Maps, and, if your garage is bigger than their shop, you pretty much safe to say you need to keep looking for another integrator. So this kind of concludes my portion of the presentation. I do want to thank everyone and my co-host and Nicole for your time today. I'm going to send it back to Nicole, but I certainly love to see some questions on the chat as I'm looking. But Earl and Josh and I are anxious to answer any of those for you. Nicole?
All right. Well, thank you guys for all that great information about end-of-line solutions. So we did have one question in the chat, but it looks like Earl answered it, but it was about rate. And another question that we did have also is, what kind of time frame are you looking at with a one of those large systems that we were showing? You guys have a answer for that?
I'll answer that. I went off
Okay.
mic. So yeah, it really depends on the information that's coming into the process that's being fed to us by the customer. I would say from the point where the design is frozen to the time where the system's up and running, you're going to be looking at probably in excess of 40 weeks, realistically. Typical single line palletizer might be delivered in anywhere from 18 to 24 weeks, as long as your integrator is not swamped at the moment. But these bigger central palletizing systems can easily take twice that.
Okay. All right, so as of right now, that is all the questions that we have, but we're going to be staying on the line for about 5 more minutes. So if you do have another question, just add it to the chat window and we will get with you. But I want to just one more time thank you and thank all of our hosts, Earl, Jim, and Josh, for sharing the information today. Here's their information or their emails that you can use to contact them to ask questions later. And this webinar will be, is recorded, and we will put it on demand probably Monday. We'll send you an email with the on-demand version. So if you wanted to go back and look at anything. And lastly, make sure you join us next month when we talk about Industry 4.0. And this is going to be showing our factory focus dashboard, which gives all your production and robot information.